Section 1.7, Exponential Functions. In this section, we're going to review one of the more common functions in both calculus and sciences. However, before getting to this function, let's take a much more general approach to things. Let's start with b is greater than 0, where b is not equal to 1. An exponential function is then a function in the form f of x, which is equal to b to the power of x. Note that we avoid b is equal to 1, meaning the base being 1, because that would give the constant function f of x, which is equal to 1. And we're also going to avoid where b is 0, since this would also give a constant function, and we avoid negative values of b for the following reason. Now, let's for a second suppose that we did allow b to be negative and look at the following function. So g of x is equal to negative 4 to the power of x. Let's do some evaluation here. G of 2, which is equal to negative 4 squared, which is equal to 16. Now, g of 1/2 is going to equal negative 4 to the 1/2, which is equal to the square root of negative 4, which is equal to 2i. So for some values of x, we will get real numbers, and for other values of x, we will get complex numbers. So we want to avoid this, so if we require b to be greater than 0, this will not be a problem. Now let's take a look at a couple of exponential functions. Example 1, we're going to sketch the graph of f of x, which is equal to 2 to the x, and g of x, which is equal to 1/2 to the x. So first, let's get a table of these values for these two functions. If we plug in negative 2 into the value of x, negative 1, 0, 1, and 2, to find f of x, then this becomes 2 to the negative 2 power, which is equal to 1 over 4. 2 to the negative 1 is equal to 1/2. 2 to the 0 is equal to 1. And 2 to the 1 is 2. And 2 to the second power is 4. Now, if we look at g of x, and we have 1/2 to the x, and now we're going to convert and use the values of x for x. Okay, 1/2 to the negative 2 power is taking the reciprocal and raising it to the power of 2. So 2 squared is equal to 4. If we have 1/2 raised to the negative 1, taking the reciprocal, 2 to the positive 1 is 2. Any number raised to the power of 0 is going to equal 1. 1/2 raised to the 1 is going to be 1. And then 1/2 squared is 1/4. Now let's take a look at the sketch of these two functions. So f of x in red is an increasing function. And g of x, which is 1/2 as the base, is a decreasing function. So this graph illustrates some very nice properties about exponential functions in general. So, properties of f of x, which is equal to b to the x. If we plug in 0, we know it's going to equal 1. So the function will always take the value of 1 at x is equal to 0. F of x does not equal 0. An exponential function will never be 0. F of x is greater than 0. An exponential function is always positive. Number 4, the previous two properties can be summarized by saying that the range of an exponential function goes from 0 to infinity. So by looking at the graph, it goes from 0 to infinity. Number 5, the domain of an exponential function is negative infinity to positive infinity. In other words, you can plug every x into an exponential function, so you can see there. And now, in part 6, if b is in between 0 and 1, then as f of x approaches 0, then x approaches infinity. So, and if f of x approaches infinity as x approaches negative infinity. Now, if b is greater than 1, then the function approaches infinity as x approaches infinity, and if f of x approaches 0, then x approaches negative infinity. So let's talk about that. If the value of b is in between 0 and 1, that means the base is going to be a fraction. And it's saying that if the function approaches 0 as x approaches infinity. So let's take a look at this one. Our base is 1/2. It's in between 0 and 1. And the function is approaching 0. And so does, and x is approaching infinity. Now, if the function was approaching infinity, then x would be approaching negative infinity if we had a value in between 0 and 1. Now, if the base is greater than 1, for example, here we have 2, so we know that that's greater than 1. And if the function is approaching infinity as x approaches infinity. Now, if you look at the function here, the function is approaching 0 as x is approaching negative infinity. Now, these will all be very useful properties to recall at times as we move throughout this course, and later calculus courses for that matter. This is a very important exponential function that arises naturally in many places. This function is called the natural exponential function. However, for most people, this is simply the exponential function. Now, the definition, the natural exponential function is f of x is equal to e to the x, where e is equal to 2.7182818, so on. Now, since the value of e is greater than 1, we also know that e to the x approaches infinity as x approaches infinity, and e to the x approaches 0 as x approaches negative infinity. So let's take a quick look at an example. Here we want to sketch the graph of h of t, which is equal to 1 minus 5e to the power of 1 minus t over 2. So let's first get a table of values for this function. We're going to let t go from negative 2 all the way to 3, and then we plug it into our value of t. So the output when t is negative 2 is negative 35.9453. The output for when t is negative 1 is negative 21.4804. The output for when it is 0 becomes negative 12.5914. The output for when it is 1 is negative 7.2436. The output for when it is 2, the result is negative 4. And the output when t is 3 is negative 2.0327. So now here is the sketch of this function. Now, the main point behind this problem is to make sure you can do this type of evaluation, so make sure that you can get the values that we graphed in this example. You will be asked to do this kind of evaluation on occasion in this class. You will be using exponential functions in pretty much every chapter in this class, so make sure that you know that you are comfortable with them. So, let's go ahead and just plug in the value of negative 2 into a calculator. Okay, so if we want to be able to do this, we're going to plug in negative 2 into the value of t. So we have 1 minus 5, and then we're going to find the value of e, which is above the division bar, using the second button, which is e. Then we're going to raise that e to a power where it's going to be 1 minus, it's going to be negative 2 over 2. So if you want, we can write negative 2 divided by 2 in parentheses, and then we got to close it again, and then hit enter, and we get negative 35.9453. So you just got to be careful that when you go about this, just make sure that you're using the correct parentheses when you're plugging in this information. So it's really important to make sure you know how to do that. And therefore, that concludes the review on exponential functions.